Hi everyone, welcome back to the GCSEMathsPro YouTube channel. In today's live, we will be walking through, as you can see here, Edexcel Paper 3 for Foundation Tier. This is June 2023. On Monday, we went through the Paper 2 for the same year. So if you want to look at Paper 2 as well, you can go back onto my channel and look at the Lives playlist. It will be in there. So we're just going to make a start. Make sure you have your scientific calculator with you as well. So question 1, write the number 3,107 in figures. So 3,100, and then the 7 is like in the units, isn't it? So technically it would be like this. So you've got effectively a gap, haven't you, between. Would I recommend this as extra revision for higher? No, I wouldn't, to be honest, because the last kind of, I don't know, between 5 and 8 questions of this paper are on the same paper for higher tier. So you would have done those questions anyway. They're exactly the same questions, right? The last ones on this paper are the first ones on your paper. But also then the rest of it, I don't know if it's like that helpful particularly. So I'm not sure if I would. You can always look at if you've already done all of the past papers for higher tier, you can always look at the old past papers for higher tier. So the ones before 2017, if you just Google it, you'll find them. The old spec. You could do that as well, because I mean the maths is still kind of, the same thing, isn't it? So if you want more papers, that's what I would do. But yeah, I don't know if this would be massively helpful because you've already done some of the questions on the paper anyway, on your paper. Okay, so write 3/10 as a percentage. So let's grab our calculator, because we might as well use that. I mean, unless, if you're happy to just write the answer, then go for it. That's fine. But what I would do if you're not sure is just put the fraction into the calculator. And if you press this little SD button, it will convert it to a decimal. Now, when we have decimals, if we want to make them into percentages, we can just times by 100. So it's 30%. So that's one way of doing it, unless you just looked at it and were happy to write down the answer, that's also fine. So simplify m plus m plus m plus m. You're just counting how many m's do we have. We have 4. So 4 and then m there. There's just 4 of them. Scroll down a bit. So change 4,000 grams into kilos. So you do need to know this conversion. This is one of the few conversions you do need to know. So we just need to know, the way that I kind of remember is like, if anything begins with K, so like kilograms, kilometers, that kind of thing, K normally represents 1,000. So what we're saying here is that there are 1,000 grams in 1 kilo. So, well, how many is 4,000 grams? That's just 4 times the amount, isn't it? So that would be 4 kilos. And question 5, we've got 7 minus 5, 3, 9 minus 2. Write these numbers in order of size. Start with the smallest. So the smallest is, if you think about a number line, is -5. That's the smallest number. Then the other negative is -2. Now we're going into the positive, so that's a little bit more obvious, isn't it? 3, and then 7, and then 9. Okay, so you've got a nice selection of 1-mark questions there. Question 6, the diagram shows a shape on a centimetre grid. Find the area of the shape, first of all. So let's see, we've got, when it says centimetre grid, it just means like each kind of box is 1 centimetre. So technically each box, I guess, would be 1 by 1, wouldn't it? 1 centimetre squared. So I guess you could just count how many boxes there are, how many squares there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That would be 14 centimetres squared, wouldn't it? It's only 1 mark, so there shouldn't be too much working out either. Then we want to find the perimeter of the shape. That's just around the outside. So again, I'm going to count, but I'm going to count the edges. So maybe if I get a highlighter, we can see it. So we've got 1, 2, 3 here. 4, 5, 6. And then 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. There we go, roughly like that. So you should get 18 centimetres. So the perimeter is around the outside. The area is like the inside, isn't it? So that was for 2 marks in total. Question 7. Here is a 4-sided spinner. You can see that we've got the numbers 1, 2, and 2, and then 3. Samina spins the spinner once. Choose the word that best describes the probability that the spinner lands on 2. So if you have a look, all of these sections are equal, aren't they, basically? But the 2 is on 2 of the sections, isn't it? So it's on half. There's only 4 sections. It's on half of the sections, isn't it? So what are the chances? Basically 50-50, which if you look at these if you look at these words, would be like an even chance, isn't it? It's 50-50. So that one, we'll write it here, evens. And then choose the word that best describes the probability that the spinner lands on a number less than 4. So if you think about it, 3, 2, and 1 are all less than 4, aren't they? They're all less than 4. So that's certain, isn't it? That's 100% guaranteed, because all of the options that could happen are less than 4 anyway. So let's just scroll up because we've got part C down here as well. So Ralph rolls a biased dice once. The probability that he gets the number 5 is 0.4. Work out the probability Ralph does not get the number 5. So he gets any of the other 5 numbers, right? He can't get number 5, but there are technically 6 numbers on a dice. So, you know, the chance of getting any other number that isn't the 5. Well, all probabilities add up to 1. That's the fact that we need to remember. All probabilities will add up to 1. Or if in other words, 100%. So if we want the opposite of the number 5, which is everything else, then I just need to take I need to take 0.4 away from the 1. So it's almost like saying 100% minus 40% if you want to think about it that way. Same thing, isn't it? So the probability would be 0.6. Okay, 0.6 for that one. So just take it away from 1. And that's 3 marks for all of those. Question 8. A quadrilateral has 4 right angles and 4 sides of equal length. So a quadrilateral has 4 right angles and 4 sides of equal length. Write down the mathematical name of this quadrilateral. So it's a 4-sided shape, but they're all right angles and each side is the exact same length. So that's obviously therefore going to be a square, isn't it? Because when it said right angles, I was thinking it's either a rectangle or a square, and then it said equal length. Then I was like, no, yeah, that's a square. The diagram shows a solid shape here. Write down the mathematical name of this shape. So that is, we just have to know that's a cuboid, isn't it? It's a 3D rectangle, basically. So you have to say cuboid. Another 2 marks there. Okay, the table shows the number of books read by 4 people in 1 month. So you've got the people, you've got the number of books. Work out the median number of books. So the median means the middle number of books. So we can put the numbers in order, basically, don't we? They're not currently in order here. And we've got 2 marks, so we do need to have some kind of working as well. So a little bit of working and then an answer is what we're looking for. 1 mark for the answer, 1 mark for the working. So if I put them in order, I get 1, 5, 7, 9. And then I want the middle number now, because there are an even number, isn't it? I've got 4. Because I've got an even number, technically the middle number is between these 2, isn't it? Because, you know, I don't know if you've gone through where you cross off each side, cross off that pair, cross off this pair. There's nothing left, or it's obviously the middle that we need. So you just need to work out the middle between 5 and 7, which, if you think about just the number line, it's 6, isn't it? So put them in order and then choose the middle number. So that might be, if it was an odd number here, then you would just choose one of those numbers. If it's an even number, you have to choose, you know, halfway in the middle, literally. Then we've got part B, find the range. So that's the difference between the biggest and the smallest. And now that we've got them in order, you can see that obviously the biggest is 9, the smallest is 1. So the range would be 8 if you take those away from each other. Now we also have a bar chart as well. So on the grid, draw a bar chart to show the information in the table. We need to label, obviously, the axes as well, I would suggest. And to figure out a scale. So we know that we've got, hang on, I don't even quite see my numbers there. There. Our biggest is 9, isn't it? So if we count just to figure out a scale, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10 squares. Our biggest number is 9. So I'm going to take each square as, you know, one book to represent one book. So what have we got? We've got Jimena first. Jimena has 7 books. So let's draw a bar for that. We've got 4 people. Let's see actually also how wide we can make them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that's quite random actually. Okay, so 1. I could probably make them 2 wide each, I guess. 1 here, 1 here. I'm just planning it out in my head. Oh no, that would be too big, wouldn't it? Let's go with 1 square wide. You kind of have to figure that out, don't you? So Jimena was 7, so I'm just going to put Jimena here. Obviously, let me make that smaller. You would obviously use your ruler and a pencil. So for Jimena, we had 7 books. I'm going to use 7 squares up. So that's 2, 3, 4, 5, 6, 7. Roughly like that. Obviously, write the names. Who did we have next? We then had Martha, who has 9 books. So it was read 9 books. So I'm going to go across a little bit. And then obviously 2 higher. Yours will look a little bit nicer than mine, hopefully. Mine's just a little bit difficult to do digitally. Right, let me move Jimena over actually. Jimena here, we had then Martha, didn't we? And then we had Kezia with 1 book and Tabby with 5. Kezia with 1 book. And then Tabby with 5 books. 1, 2, 3, 4, 5 here. And then obviously you want to label this side. So this side is then the number of books as well, wasn't it? The y-axis. Number of books. And then put a scale. So this is 0, 1, 2. You get the gist. 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So something a bit like that. We've got a bar chart. You have to have the correct people labeled. You have to have the correct scale, and yeah, label both of the axes as well. Yeah, person and number of books. You could write person down here, I guess, because that was the heading of the table, wasn't it? Person. There. Yeah, let's do that. So there we are. We have 3 marks there. Question 10. Wayne begins walking at 8:30 a.m. He walks for 1 hour and 45 minutes. Wayne then rests for 15 minutes. He then walks for 85 minutes to a cafe. Does Wayne get to the cafe before 12 noon? So it's just time basically, this one, isn't it? We want to do 8:30, adding an hour and 45. So that'd be 9, add 1 hour would be 9:30, wouldn't it? And then add 45 minutes. So that would be 30 minutes up to 10 and then 10:15, wouldn't it? So 8:30 plus 1 hour. I'm just writing something down for some working, isn't it? Just to get some working. That would give me 10:15 a.m. He then stays there or rests for 15 minutes. So then that would be obviously 10:30, wouldn't it? 10:30 a.m. and then he walks for 85 minutes. So 85 minutes, if we take away 60, because 60 minutes is 1 hour, isn't it? $60 minutes is 1 hour. And then there's 25 left. So an hour would be 11:30 plus 25 minutes would be 11:55, wouldn't it? 10:30 plus 85 minutes. Just write something down so you've got some working out, basically. I know it's kind of, you can kind of do it in your head, but... Sorry guys, I don't know why the thing keeps shutting down. Normally do that. So yeah, as I said, we just want to write some kind of working out, and then obviously we then want to write, they've asked, does Wayne get there before 12? Well, oh, I meant to write 11 there, didn't I? 11:55 a.m. So therefore that's before 12, like midday, isn't it? So you want to write yes. Obviously if it was no, you want to write no, but we need to write a confirmation of yes or no. So that's how I would just figure it out. I mean, however you like to work it out, as long as you end up getting, you know, something before 11, before 12, 11:55, then that's fine. You can obviously add them all together, the times, if you want, and add it all in once. It's up to you how you want to go through it. Just write down some kind of working out, obviously, for the 4 marks. So question 11, Gabriel thinks of a number. He multiplies his number by 5 and then adds 7. His answer is 72. What number did Gabriel think of? So we're kind of working backwards here. Is the signal not very good? Maybe I need to swap Wi-Fis. Yeah, I'm not sure what's going on with the audio then. It says green right now. Oh no, it's gone back to red. Yeah. Is the audio for everyone else not very good either? So obviously that's not very helpful to you guys, is it? It keeps refreshing on my page. I don't know if it's doing the same on yours. It keeps kind of like loading. Let me see if I can swap Wi-Fi. All right. So as I said, we need to work backwards here, don't we? So I'm sorry guys, I might have to stop the stream because for some reason my laptop keeps shutting down over and over again, and I'm not sure why. Which is obviously disruptive for you guys. We'll give it one more go, and if it shuts down again, then I'll stop the stream and we'll try and do it another day. So he's taken a number. I like to just use algebra. You don't have to. You can use X, you can use N, any letter you want. So let's say his number is X. It's an unknown number, isn't it? So we'll use X to represent that. He multiplies his number by 5. So how would I write that? I would put 5X. And then he adds 7 plus 7. And his answer, so equals 72. This is how I would figure it out. You don't have to necessarily do it this way, but this is how I would figure it out. So all I need to do is then just solve the equation. It depends if you're happy to use algebra or not, really. You might want to work it out without algebra, that's fine. I quite like to use algebra. So I can clearly see I need to take away 7. Take away the 7, which gives me 65, and then divide by 5. It's basically the reverse of what they've done here, but obviously do the 7 first and then the 5 second. So if we divide that, I think we should get 13. So Gabriel's number was 13. So however you want to work it out, hopefully you would end up with 13 at the end though. Question 12, some students take a guitar exam. The pie chart shows information about the grades the students got. So we've got fail, pass, merit, or distinction. Write down the modal grades. The mode, or modal grade, or modal class, that kind of thing, is the one that is the most, isn't it? So in this case, it would be the biggest section. So I would say merit is the biggest section of my pie chart, isn't it? The merit bit. Then we've got 7 students got distinction. So this is actually equal to 7. Work out the total number of students who took the guitar exam. So the whole pie chart basically, isn't it? Work out the whole pie chart. So if we know, this is why they've given us the angles. When you've got a pie chart, you tend to have to work with the angles. If we know that 105 degrees of our pie chart represents 7 students, doesn't it? And then the whole pie chart is 360 degrees, isn't it? Because this is around a point, it's a circle. So what I think I would do is, you could, 105 is quite a random number, isn't it? So you could kind of work out how many students maybe 1 degree would represent. I know it'd be like a really small decimal, and then times it by 360. So what I might do is, let's say 7 divided by 105, which I know it'll be tiny, but we can put it in the calculator, and then times it by 360. And that would give me my whole pie chart. Let's get the calculator, because obviously we're not going to do that ourselves. So we've got 7 divided by 105. As you can see, you get 1/15, or you get, you know, a really tiny, obviously that's, you can't have 0.06 of a person, but we'll just bear with that. Then you times it by 360 degrees, because that's how many is in a pie chart in total, isn't there? Now I've got an actual number that makes more sense, haven't I? 24. You obviously have to have a whole number of students. So that makes up the whole thing. You can obviously go through and work out 150, 75, 30 and add them all together if you wanted to. You'd still get the same answer, but I just don't see the point, really. You might as well just do it directly. So 24 students are in the pie chart. Question 13. So Rowena drove from her home to a beach. Here is a travel graph for her journey. So Rowena stopped at a cafe on her way to the beach. How many minutes did Rowena take to drive to the cafe? So basically, she obviously started at her home. She drove to the cafe, she stopped, and then from the cafe she drove to the beach. So you can see we've got time here, we've got distance from home. So this flat bit here is obviously when she stopped, because there's no more distance, is there? She's not getting any further away. So I'm going to assume this is where she's in the cafe. So how many minutes did Rowena take to drive to the cafe would be from obviously starting at 12 and then up to this point. So you just have to figure out the scale of the graph. We've got 12 o'clock here, this is 1 o'clock, and this is exactly halfway. So that would obviously be 12:30. But they've asked for how many minutes that would be, so that's 30 minutes, isn't it, from 12 to 12:30. Well, let's look at part B. So write down the distance from Rowena's home to the cafe. So again, to this point, let me get a colour. This is the point where she gets to the cafe, isn't it? It was 30 minutes, but in terms of distance, that's the y-axis. So you can see that's 10 miles. 10 miles to the cafe. Now I think there's a part B on the next page, so we'll flip back in a minute. So Rowena stayed at the beach for an hour and a half. She then drove home without stopping. Rowena arrived home at 4 o'clock. Part B on the grid, complete the travel graph. So she stayed at the beach for an hour and a half, so she didn't move. She then drove all the way home. She got home for 4 o'clock. So let's go back. So she stayed at the beach for an hour and a half. So that's just going to be, again, another one of these flat lines because the distance hasn't changed, has it? She stayed there for an hour and a half. So she gets to the beach. What time is this? That's 1:30, isn't it? So an hour and a half. So you'd get to 2:30 and then 3 o'clock, wouldn't it? Be an hour and a half. So I'm going to draw just a flat line to 3 o'clock. That's how long she stays at the beach, an hour and a half. And then it takes, well, she gets home by 4. So we're just going to draw a straight kind of diagonal line from there to back home, because obviously back home is 0 miles from home, isn't it? Okay, so that would be part B. Now there was also part C, so work out the average speed for the journey from the beach to Rowena's home. So from the beach back home. So we've got a distance and a time graph. The speed is therefore basically the gradient of the line, but we're not using the whole graph, are we? We're starting from here until she gets home. So we're talking about this line here. What is effectively the gradient of that line? So the gradient is the change in y over the change in x, isn't it? So you can check. The change in y is obviously from 0 to 35, isn't it? So that's 35. The change in x in terms of time is from 3 o'clock to 4 o'clock, which is 1 hour, isn't it? So do you see how that would be 35 just over 1? Which is also distance divided by time, isn't it? The distance that she travelled was 35 miles. The time that she travelled was 1 hour. So 35 divided by 1 is obviously just 35, isn't it? So that's, I think, why they've put 1 mark there. 35 divided by 1 is just 35. Question 14. So we've got 120 boxes cost £6. 270 bags cost £10. A bag is cheaper than a box. How much cheaper? So we need to work out what the cost of one box, the cost of one bag, and then the difference. So the cost of, what have they said? They have said to give your answer in pennies or in pence. So you can obviously convert it now. You can convert it at the end. I think because the 120 is quite big, I might just convert them now. So there are 100. Well, there's 100 pence in a pound, isn't there? So therefore, that's obviously 600 pence. Now, I want to see how much one box costs, not 120. So I'm going to divide that by 120. So 600 divided by 120 is 5. Now, that was in pence, isn't it? 5 pence. So one box costs 5 pence. And I'll do the same for the bag. So again, I'm going to convert it into pence. So that's 1,000 pence, and then divide by 270. 1,000 divided by 270 gives me basically 3.7 pence, isn't it? 3.7 pence. So that's a bag. And then they've said, well, how much cheaper is the bag? So we want to know the difference, don't we? The difference. So I would do 5 minus, I'm going to just take away my whole answer. That will copy your previous answer. And that will give me, they want it to one decimal place, don't they? So that's 1.3. Well, you can see here as well, I rounded it 1.3. So 5 minus 3.7 is 1.3. And because I converted it into pence in the beginning, that's just my answer. You might have used pounds here, which is fine. And then just obviously make sure you do convert it into pence at the end if you've done it that way. That's also fine, but just, yeah, make sure you give your answer in the correct format at the end. So question 15, there are only red beads and green beads in a bag. The number of red beads to the number of green beads is 1 to 4. So I like to just label them like this, red to green, 1 to 4. There are 35 red beads in a bag. So I would put 35 on the side of the red. Work out the total number of beads in the bag. Okay, so we've got ratio where we're told one side, aren't we? We're told one side of the ratio in actual reality is actually 35 red beads. So what we're saying is the 35 beads is equal to that ratio. So one part of the ratio is equal to 35 actual beads. So I want to know, well, again, I guess there's two ways you could do this. You could work out green and then add them together, or you could just work out all of them. In total, of red and green, there are 5 parts, aren't there? So if one part is 35 beads, I could just work out 5 parts by timesing 35 by 5, couldn't I? Times it by 5, you should get 175, and that's the total. So that's the red and the green together. So you could work out green on its own, but you don't technically have to. You can just work it out directly. As long as you get 175 in the end, 175, sorry, in the end, then that's okay. Question 16, describe fully the single transformation that maps A onto B. So from A to B. So it's not changed size or anything, has it? I think what it looks like here is some kind of rotation, isn't it? It's kind of flipped around. So there's the first thing is what type of transformation is it? It's a rotation, but we also need to mention some information about the rotation. You can't just write rotation, right? You have to say something about it. So what can we say about a rotation? There's two pieces of information we need to know. One is the number of degrees, and possibly also including the direction. So 90 degrees, 180 degrees, that kind of thing. Now, you should be able to get tracing paper in your exam, so you can always use that to kind of figure it out if you want. But the way that I've just looked at it is I'll look at one of the sides of the triangles. Let me go highlighter. Let's say I look at this side, and then I match it on B. Do you see how that would be this side here? Originally, it was horizontal. Now it's vertical. What kind of rotation is that? To go from horizontal to vertical, that's obviously 90 degrees, isn't it? That's obviously 90 degrees. That's how I kind of think. If I don't have tracing paper, that's how I figure it out. So I would say 90 degrees. Now, if it is 90 degrees, you do have to specify, is it clockwise or anti-clockwise? And I would say because we're going from A to B, it's going like that way, isn't it? It's going kind of backwards. So that is anti-clockwise. If it's 180 degrees, you don't have to say clockwise or anti-clockwise because it would happen either way. It doesn't really matter. And then there is one more other thing I need to mention. So you'd only get 1 mark if you wrote that, right? You don't get any marks for just writing rotation. You have to write at least one detail about it. That's the thing to know about the mark scheme. The other thing is then obviously the point of rotation, which I would probably work this out. As I said, if you've got tracing paper, just trace, triangle A, stick your pen on different points until it rotates to overlap with B. That's kind of probably how I would do it. That's the best thing, but I think you might have to ask for tracing paper in the exam, so I would do that. But I obviously don't have digital tracing paper. The rotation, point of rotation is here, center of rotation, because you can see it was there, and then if you rotate both of those 90 degrees, it's then like that, isn't it? That might not make sense, but it doesn't matter because you should have tracing paper in your exam. So either way, you then put 0, 0 as your center of rotation. So that all of that information would give you 2 marks. You'd only get 1 mark for saying rotation and one of those 2 things. You get 2 marks for saying rotation and both of those things. Question 17, the diagram shows the position of town T. So you can see here, they've obviously drawn a north line, so this is going to be something to do with bearings. Town R is 55 kilometers from town T on a bearing of 65 degrees. We need to mark the position of town R with a cross, and they've given us a scale, which is 1 centimeter in real life on your piece of paper is 10 kilometers on, in this kind of scenario. So what would I do first? I guess the bearing first. So you would obviously get your protractor. I don't have a digital one, but I would roughly show you how I would use it. You would line it up with the north line. So I would put it like, oh, that was horrible. I would kind of put it like this, if that makes sense. That's your protractor. Put the center of your protractor on T and then make sure it lines up vertically with the north line. And then I'm going to read clockwise 65 degrees. So start with the one that says 0 here to 65 degrees and then put a little mark. So I think I can do it. Can I do that with my line? I'm not sure. I'm going to say, obviously, I know 90 degrees is there. So I'm going to say 65 is probably roughly there. Right. So what I would do is just draw a little mark or draw a line straight through it, draw a really long line. So that's your protractor bit. Now we know that that's then 65. Let's get rid of this for now. But I need to know, well, how far along, so that's 65, how far along this line would my 55 kilometers fall? So now I need to use the scale. If 1 centimeter is 10 kilometers, they've told me I need 55 kilometers. So I would need to divide, to get back to centimeters, I'd need to divide by 10, wouldn't I? So that would give me 5.5 centimeters. So then obviously you get your ruler and measure 5.5 centimeters. Let's say I measured it and it was here, then I would mark there and I would put R. So do your bearing first, measure the angle first, just draw a really long line and then figure out how far along that line is town R. So obviously mine's just a rough estimate, but yours will obviously be more accurate in real life. So you get 2 marks for that. Question 18, we need to solve 4 brackets 2x minus 3 equals 20. So when we say solve, you can see here, the whole point is to get x on its own on one side of the equation, move everything to the other side. There are 2 kind of ways to do this. You can expand out the brackets and then move it across, or you could just divide across by 4 immediately if you wanted to. I think I'll just expand the brackets to show you. So obviously multiply 4 by 2x is 8x. 4 by minus 3 is minus 12. And then 20. I would then add the 12. So we're always doing the opposite, aren't we? If you're moving something from one side of the equation to the other, you always do the opposite. So it's currently subtract 12. So I'm going to add 12 to both sides. Obviously, if you add it on the left, it just cancels it out. It becomes 0. So it's not there anymore. And then obviously add it to 20. So that's 32. And then I just want to get x. I don't want 8x. I just want 1x. So I need to divide by 8 because currently 8x means 8 times x. It's multiplied by it, isn't it? So if I divide, obviously I get just 1x. And then 32 divided by 8 is 4. So x is 4. So that's it. As long as you got to 4 at the end, as I said, you might have done a different method. But if you get 4 at the end, then I'm assuming it was probably still correct. We've then got question 19. Jenny invests £3,000 for 6 years at Y% simple interest per year. At the end of 6 years, Jenny has received a total of £450 in interest. Work out the value of Y. So simple interest. We've got sometimes compound interest. We've got sometimes simple interest. So simple interest is just that when you work out the percentage of the 3,000, that exact monetary value in pounds, in this case, that same amount will be added every year. Now they've said it's 6 years and the total interest is 450. So I want to work out, well, what was the interest for 1 year? Not just 6, 1 year. And because the interest, the amount of money was the same every year, I'm going to divide by 6 to get 1 year. So 450 divided by 6, no, that's 50, is £75. So what we're saying is that every year Jenny received £75. Year 1, £75. Year 2, another £75. Year 3, do you see what I mean? Another £75. Okay, so that's fine. So that is Y% of £3,000. So I need to go, well, how much is that as a percentage of 3,000 then? What is 75 as a percentage of 3,000? So to work out what a percentage is, we do 75 divided by the 3,000 and obviously times it by 100 to make it a percentage, not a decimal. So 75 divided by 3,000, and then I'm going to times the answer by 100. And that gives me 2.5%. 2.5%. Okay. So that one's just working backwards a bit. It's a little bit difficult to figure out, but working backwards. But just remember the difference between simple interest and compound interest. Simple interest is the same exact amount of money every year. So you can equally share out the total interest. Okay, we've got some index laws here for the first 2 parts. Simplify m squared and then all of that cubed. So when we've got brackets, it's the 3rd index law, which means you multiply the powers, so it's still m, and then you do 2 times 3, which is obviously then 6, m to the power of 6. Now this one is different. There are no brackets. It's now, they've actually written a multiply symbol. That's our 1st index law. So you have to then add the powers in that case. When it's laid out like this, something times something else, you add the powers, so that should give you x to the power of 13. And then part C is just expanding brackets, which effectively we kind of did in the other question, didn't we, with the solving. So we're multiplying. When we say expand, it means multiply. So 4p times p squared, well, 4 times 1 effectively, still 4. P times p squared is p cubed. Technically, because that's the power of 1, isn't it, there, and you're adding the powers. And then we've got 4p times 3p. So obviously 4 times 3 is 12. P times p is p squared. So that would literally be your answer there. There's nothing to really simplify, is there? That's your answer. You can't add them together because they're not like terms. One is p cubed, one is p squared, right? So they are different. Question 21. Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup, and they're all of them that he's going to assume are going to drink the 2 cups. So Johnny assumes 68% of the people will drink coffee. So it's just kind of like a general arithmetic one, I would call this, kind of just general maths, isn't it? Figuring out different things. Using this assumption, work out the amount of coffee Johnny needs. So quite a lot to take in there. Let's have a look again. We've got 800 people in the meeting. Johnny assumes 68% of the people will drink coffee. So not all of the 800, just 68% of the 800. So to work out 68%, because we've got a calculator, you just do 68 over 100 because it's a percentage. Yeah, this is calculator paper, yes. 800 multiplied. You can obviously convert 68 into a percentage if you want, into a decimal, sorry, if you want to just do it directly. But either way, you should get 544. However you worked out here, you should get 544. You can also, if I go back, use your percentage button if you want. If I put 68, you see mine is here. I don't know if you can see my mouse. I press shift and then a percentage sign comes up. Yours might have that as well. It might be somewhere else on your calculator, but it gives me the exact same answer. So however you want to work it out, as long as you get 544 people, then that's fine. So what we're saying is actually only 544 people will be drinking the coffee, not the whole 800. Yeah, how do we do percentage? If you want to work out the percentage of an amount, obviously your paper 1 has already happened, because if I had a non-calculator paper, I would obviously do it differently, but that's already happened. So now we're focusing just on how can I do it with my calculator. You just take whatever your, the quantity is initially anyway, and then whenever you're using a calculator with a percentage, you have to have it as a decimal, which is why you always do the percentage over 100. That converts it into a decimal, doesn't it? How do I go from a percentage to a decimal? Always divide by 100. So that you can just type that in, or it's technically this, isn't it? 0.68 as a decimal. If you're happy to just do that directly, that's fine. But yeah, if you want to convert any percentage into a decimal to therefore use it in your calculator, you always divide by 100, yeah, and then times it by whatever value you want to find the percentage of. So yeah, you can see I've got a smaller number because obviously 68% is not all of the 800, is it? It's a smaller amount of 800. So I'm saying that we've got 544 people who do want to drink coffee. Now, so I've done that, tick that off, I've done that, tick that off. Each person who drinks coffee will drink 2 cups. So how many cups is that? Well, there's 544 people, but they're each going to drink 2 cups. So I just times that by 2, isn't it? So 544 times by 2, 1,088 actual cups of coffee, isn't it? So that's people, but now that's cups, isn't it, of coffee? And then, so I've done that, okay. And then the last thing, I guess, is then, well, how much coffee is that? So they've said that 10.6 grams of coffee is needed for each cup. So I've got 1,088 cups, and I want 10.6 grams for each cup. So again, I'm just multiplying. So take my answer, 1,088 times by 10.6. Obviously, you're going to get a decimal. We've got 11,532.8. 11,532.8. Now that is now in grams, isn't it? So scroll down here. Do you see how the answer has told you they want it in grams? Let's just see. They did say give it correct to the nearest gram. So even though I've got a decimal, I will round it. Obviously, the nearest gram would be rounding up, wouldn't it? Because the 8 is bigger than 5. So that would be 11,533 grams to the nearest gram if you've rounded it correctly. Now, I do think that if you wrote this as your final answer, they will still give you the mark, okay? So if you didn't round it correctly, they will still give you the mark as long as, your answer is actually correct in the first place. But technically, it should be rounded. So they've actually said for part B that Johnny's assumption is wrong. So the assumption was the 68%, wasn't it? So the assumption is actually wrong. 72% actually want to drink the coffee. So how does this affect my answer? Well, we planned it out for 68% of people. This is now 72% of people. That's more people, isn't it? So how would that affect my answer? My answer was in the context, obviously, of grams of how much coffee I would need. If I have more people who want to drink coffee, then it would just mean that I need more coffee, isn't it? You don't even need to put a full sentence, just something like that. Or maybe I'd write need more coffee. That's probably what I would write. They've suggested you can say that the amount will be more. So this will be like your answer will be bigger. My answer will need to be bigger. You don't need to actually work out the numbers or anything. I wouldn't bother about doing that. But if you did, they would give you the mark if you worked out the actual numbers. You could say that this is an underestimate, in which case you could say that for your answer to part A wouldn't be enough coffee or anything like that. I think this is probably the most obvious answer though, isn't it? Need more coffee. Do you have to show all the calculations you do on the calculator to get marks? Yes. And I'll show you the mark scheme. Look here. This part A, do you see how they've got, it was 4 marks, wasn't it? Do you see how we've got mark 1, mark 2, mark 3, and then this is just for the answer. So do you see how they've said mark number 1 is assigned to working out the 68%? So however you've worked out the 68%, they're looking for that to give you 1 mark. They want to see that you did work out the percentage, and you see their examples are something like that. Something similar to this. And in the brackets is the 544. So the mark is not for the 544. The mark is for the calculation. The fact that you then get the correct answer is obviously helpful. But yeah, and then, so your second mark is then for the correct process of then, just doing the next. Obviously, because people can do this question in different orders. So that's why they've given multiple different options, but effectively for the next step in the process. And then for the third mark, it's for the full process to find all of the coffee. So basically, we did three steps of working. That was 3 marks. And then the final mark is for your answer. Sometimes they say if the correct answer is given, but there's no working, they'll give you no marks. Sometimes it says that in the mark scheme. So just write down everything that you're doing is what I would suggest. Yeah, exactly. Yeah, just write down as much as you can, because you just never know where those method marks are going to come from. So, because just in case, because what if, you typed it in slightly wrong to the calculator, you got the wrong final answer, but then there's no marking. There's no method, written down. They can't give you any marks. Whereas if you'd written down the correct method, but maybe you just typed it in wrong to the calculator, you can still get the majority of the marks. So just make sure you're writing down as much as you can. That's kind of my best suggestion. Do you see how here I've literally got 3 stages of working? That was the 3 marks, wasn't it? That's what they're looking for. So yeah, always write your working. Just think the number of marks there are, that's how much stuff I should write. Obviously, one of the marks is always for the answer. So if you subtract 1, then that's the amount of working out I should have. So 5 marks would mean probably 4 lots of working out plus 1 answer. Do you see my point? That's, roughly, just to give you an idea. So question 22. ACF and ADG are straight lines. Where's that? ACF and, okay, so these 2 diagonal ones. BCD and EFG are parallel lines. You can see that with the little arrows. That means they're parallel, these 2 here. Show that triangle ACD, so this top one, is isosceles. And they do say give a reason for each stage of your working. So that will also add maybe 1 mark, maybe 2 marks, just depends. So the way that, think about it. What's an isosceles triangle, first of all? An isosceles triangle is a triangle where 2 sides are the same, but we don't have side lengths here, we have angles. So what does that mean about the angles? It also means that 2 of the angles are exactly the same. So what that means to me is that I'm just going to try and calculate the angles in this triangle, and hopefully 2 of them will be the same. And then I can say, oh look, it's isosceles. So I think the most obvious one is probably over here with 110, because they've said to me that ADG is a straight line. So what I know about straight lines is they add up to 180. So I could work out ADC. So ADC, that angle, is 180 minus 110, which is just 70, isn't it? You can also label your diagram as well if you want. 70 degrees. And then I would say, because my reason is angles on, it doesn't have to be a full sentence, but just write the keywords, on a straight line are 180, or add up to 180, something like that. So I've got one angle. Then I'm thinking, okay, well, I've used the 110, haven't I? So tick that off, but I haven't used the 125 yet. So what could I use that for? I've also not used the logic of parallel lines either. So think about angles on parallel lines. There's different ways to go about it, actually, but what I'm thinking is parallel lines tell me that this angle is 125, and then that can help me with the inside of the triangle. So first of all, BCA is 125. Now, the reason for that is corresponding angles. That's what it's called, isn't it? Corresponding. You just have to memorize those angles on parallel lines. There's only 4 of them. Angles, and you can say that are the same, they're equal, whatever you want to say, are equal. Then, obviously, I could work out, because BCD is the straight line, I could do the same thing as I did here. So inside the triangle, ACD would be another 180 minus 125, right? Again, because it's on a straight line. So that should give me 55. 55, which you're thinking, well, that's not the same as 70, but that's okay. It could be one of these other ones that's the same. And again, angles on a straight line. I know it's annoying to write the reasons, but you might as well get the extra marks. Obviously, if you calculated it correctly, then you must know the reasons. So then my last thing, because I haven't shown that 2 angles are the same yet, is that I would probably just work out this angle here. Now that's just due to being angles in a triangle, isn't it? And again, angles in a triangle add up to 180 as well. So that's what's that? Angle CAD is 180 minus the other 2. So minus the 55 and the, what was it, 70? So if I show you on the calculator, 180 minus 55 plus 70. This is where I'm hoping that this answer will be the same as one of the other 2. Yeah, can you see how I've got 55 again? Which is 55 degrees, and you say angles in a triangle add up to 180 or are 180. That's your reason, isn't it, there? And then, okay, now the final thing is to prove, so that one was 55 as well. Why is it isosceles? Well, those 2 angles are the same, aren't they? Those 2 angles are the same, which means it's isosceles. So I'd probably I would imagine write some kind of conclusion, because it says show. So which angles are the same? We had ACD is the same as CAD, and they're both 55. And I go there, this little thing means therefore. Isosceles, just copy the word that they've got there. I know it's kind of hard to spell it. Isosceles. That's probably what I would do. 5 marks. So let's see. Actually, that's probably kind of interesting to see how they've distributed the marks for that one. So you can see here, mark 1, method to find, well, there's obviously like 5 different options of which order you could have done it in, right? So it just depends. But we've got here finding any of these angles. So either the 55 or one of the other ones, that's fine. So you get mark for finding one of the angles, the mark for the other angle, which I did 70 first, but they did it second. Doesn't really matter if you don't do it in the same order. But either 1 mark for finding 55, 1 mark for finding the 70. Your 3rd mark is for the fact that you did find that 2 angles were 55. So you've got, in this case, only 3 marks for working. They've actually given you 2 marks for the reasons. Sometimes it's 1, sometimes it's 2, it just depends. So it's definitely worth writing down the reasons. So do you see how they've underlined certain words? If you can see here, underlined words need to be shown. Reasons need to be linked to their method. So just as long as you've written it next to it, so it's obvious. So for one correct parallel lines reason, so I used corresponding angles, didn't I? You could have used different things, but I used corresponding angles are equal. So you had to say the word corresponding. And then for the other mark, for one other reason stated linked to their method. So I put like 4 reasons, but technically they were only looking for 2, but you just never know. So I write all of them. So either you could put angles on a straight line, add up to 180, angles in a triangle add up to 180. Those are the two things that I used. They've given you loads of different options actually, because with angles questions there's normally a few different ways to do it, right? So you might have done it differently to me again, that's fine, as long as you got the 255 degrees. So yeah, make sure you write your reasons, because that is worth it. I think it's worth those extra 2 marks. Is there much difference between paper 2 and paper 3 for foundation? I think I just feel like because they're both calculator, they could put any topics in either of them. So I think what I would do, and that's why, I mean, today we're going through a paper 3, on Monday we went through a paper 2, because I would just revise both. Like I would ultimately revise pretty much everything, because you just never know what's going to come up. Yeah, it's quite hard because you want to limit your revision down, but I just think between paper 2 and paper 3 you can't really. Obviously after paper 2 you then got a bit of an idea of what's left on the syllabus, what they haven't asked yet, and then you can kind of maybe narrow your revision down a little bit for paper 3. But for paper 2, going into it, I would just, if you're doing past papers, do both paper 2 and paper 3, because they're just calculated generally, aren't they? I don't think there's a whole lot of a distinction between them, no. So yeah, you should revise all the same topics for both. So 23, it takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take for 4 of these pumps to fill another water tank of the same size? This is quite a repeated question actually. Obviously the context of a water tank or whatever is different, but the method is the same. Now, it's technically inverse proportion, the general topic, but it's inverse because, think about it, if I have more pumps, it's going to take less time. That's inverse, isn't it? More pumps, less time. If I have fewer pumps or less pumps, it's going to take more time. So it's like the opposite, isn't it? So in this case, you just have to memorize the steps. It's only 2 marks. You can see it's quite a straightforward calculation. What I want to do is first of all work out, okay, well, how long would it take if I only had 1 pump? Now, I feel like naturally you want to divide. You want to go 14 divided by 5 would give me 1 pump. But that would be if it was not inverse, right? If I have fewer pumps, it's going to take much longer. So it's going to take 5 times as long if I only have 1 pump, isn't it? One pump is going to take 5 times as long. So the first thing you just remember, just multiply the 2 numbers. So multiply that, 14 by 5. So that's 70. So if I only had 1 pump, it's going to take 70 hours to fill the same water tank. But they then said, actually, I have 4 pumps. So it's going to take me 4 times less, isn't it? So now for 4 pumps, now is when I would divide the 70. So it's kind of the opposite. I feel like what you'd want to do naturally is divide and then times, but it's actually the opposite way around. So divide, just take your answer, divide it by 4. We obviously get a decimal, 17.5 hours. So you can see when I had 5 pumps, it took 14 hours. Now that I've only got 4 pumps, that's less, isn't it? It's taking me a little bit longer. So that would make sense. 17.5 hours. Yep. So always times and then divide on those questions. Question 24, we have A and B are numbers such that we've got the product of prime factors. So A is 2 squared times 3 to the power of 4 times 7. B is 3 squared times 7 squared. Find the highest common factor. So the way that I do it is when it's already in its prime factors. You don't need to work out what the original numbers were at all. You can, but you don't need to. I like to use my Venn diagrams. So I'll get a circle. You can just scribble a circle. It doesn't always have to look that nice. Just get like a circle. Do you see what I mean? I'm making a Venn diagram. So for this one, that's A, that's B. Now, we work out what's in the middle for the highest common factor. So what do they both share? They don't both have 2's, do they? So ignore the 2's. In terms of 3's, they at least have 3 squared in both, don't they? So they have a 3 and then a 3. And then that's 2 lots of 3. You can always write it out like this if you want. A is 2, 2, 3, 3, 3, 3, 7. And B is 3, 3, 7, 7. So do you see what I mean when I said they have both got two pairs of 3's, haven't they? Those ones in common. What else do they have in common? Only 1, 7. So I'll write 1, 7. Now you can fill out then the rest of it. I guess we would, because part B is then the lowest common multiple. So once you've done that, the rest goes on both sides. So for example, A would have 2 3's and 2 2's, and then B would just have a 7. So I've filled out the whole Venn diagram. the ones they have in common, do you see how I only wrote 1 3 to represent the pair of 3s and 1 3 to represent the other pair and 1 3 to represent the 7, if that makes sense. And then the rest goes on the outside. So for the highest common factor, all you need to memorize is that it is the overlap multiplied together. So all I now need to do is multiply 3 times 3 times 7. 3 times 3 times 7 is 63. So that's our highest common factor. And then part B is find the lowest common multiple. Now I'm going to use my same Venn diagram whilst I'm here, might as well. Now that one is obviously then different, isn't it? That one is you multiply everything together, the whole Venn diagram, which is why I filled out the rest of it in part A as well. That's everything, because obviously the lowest common multiple is a bigger number, isn't it? So 2 times 2 times 3 times 3 times the other 3 and another 3, 7 and 7. Now it's not, it kind of looks like it's all of these numbers, but it's not, because remember that we only put one number to represent the pair that they had in common. So it's actually not the exact same as just multiplying all of those numbers originally. So don't do that. Calculator. Move it somewhere where we can see. There we go. So just multiply them all together. 2 times 2. You can obviously put powers if you want. Times, just make sure you've counted the right number. 4 3s, I think. Yeah. Times a 7. Oh, I've got rid of a 3. Times a 7 times another 7. And you see you've got obviously a massive number, 15,876. So your highest common factor is actually the smaller number, and your lowest common multiple is actually the biggest number. I guess that's the most confusing bit about it. But if you memorize that, then yeah, that's it. And that's 3 marks. Question 25. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. How many days does it take? Oh, so they said days, and this is in seconds, so just be aware of that. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? And you can see to the nearest day. So we've got a bit of a conversion there as well, I guess. So I think I would probably just divide it straight away. So the 67 million, divide that by the 11.9, because they're both in meters cubed at least. So that does match, doesn't it? Obviously, get your calculator for that. 67,205,600 divided by 11.9. Now this number is how many seconds it will take, isn't it? How many seconds? Because it said meters cubed per second. That's how many seconds. So what's that? 6, 4, 7, 5, 2, 9.4. Obviously dot, dot, dot. That's how many seconds it will take. So I've dealt with the actual rate. Now I just need to go, well, how do I go from seconds to make it into days? That's the bit that we now need to figure out. So I think I just do it in little stages, basically. I go, right, well, seconds to minutes, minutes to hours, hours to days. That's probably what I would do. So how many seconds are in a minute? Obviously 60. So it's going to be fewer minutes, isn't it? So I would divide that answer by 60. Kind of annoying because you have to keep copying the answer. But anyway, write down the working, as I said. Here, for example, they probably give you 2 marks for working, 1 mark for the answer. So as long as you've got, a decent amount of working. I got all the numbers there. 4, 7, 5, 2, yeah. Divide it by 60. Now you can do this all in one step, or you can do it separately, but I'll just show you separately. So divide that by 60. That's how many minutes it is, isn't it? So 94,125. 94,125 minutes. Obviously, to go from minutes to hours, you divide that again. Like I said, you don't need to write this all in one, multiple steps. You can just write it in one big step if you like. So divide by 60 again, because there are obviously 60 minutes in an hour. So this is how many hours we've got. 1,568. Obviously dot, dot, dot. Dot, dot, dot. Hours. Now I want days. How many hours are in a day? 24. Divide by 24. So that's how many days I've got. So let me just write that down. This one divided by 24 gives me about 65 dot, dot, dot days. Now they've said to the nearest day. So because it was 65.3, then yeah, I would round it down to 65, wouldn't I? 65. Like I said, this kind of section here, you could just divide by 60 times 60 times 24 if you wanted, all in one step. That's fine. I was just kind of over-explaining it. As long as you get to 65 at the end. They have obviously accepted a few other options. So obviously 65 is the main answer, but they will accept anything between 65 and 65.4. So if you wrote down the 65.3 ... then that would be fine. They have said they'll accept 66 as well. So maybe if you'd rounded it differently to me, you might have ended up with 66. So they'll accept any of those, technically, but 65 is the ideal answer. Question 26, here's the graph of y equals x squared minus 2x minus 2. So we've got a quadratic graph, which is obviously a U-shape. Write down the coordinates of the turning point of the same graph. The turning point is where it changes direction, right? So that's this bit here, isn't it? So the turning point is at on the x-axis 1 and on the y-axis minus 3. So that's literally it for that one. And then part B, write down an estimate for only one of the roots of x squared minus 2x minus 2 is equal to 0. Okay, let's go through that. Roots is another way of saying solutions, which if you think about solutions is solving it. When we solve things, it's x equals. What is x? Now, I'm obviously going to look on my graph. When I say write down, and there's only one mark, it basically means there's no working out to do. It's just the answer is somewhere already in the question. You just need to find it. So, you got a highlighter. The way that I explain this is, look at the original graph. Let's do this one. This bit, you see, is the same as this bit. I know it's on the other side, but it doesn't really matter which side it's on. So therefore, what was on the other side? Y originally is now 0, isn't it? Do you see what I mean? Like y is now 0. So what that tells me is they're saying when, you don't have to write this on your actual working, but just to show you, when y is 0, that's where we're looking. So when y is 0 is the x-axis, isn't it? That's where y is 0. So you're just seeing where your graph, the curve, crosses that line. Now, obviously, quadratics normally have two solutions, don't they? They have these two. For some reason, they've only asked for one of those. So you just write down either of these two, whichever you prefer, basically. So I might go with the positive one. Let me get rid of my circle so we can read it properly. Just be careful of the scale as well. I'd do it to maybe like 1 decimal place. So it's obviously 2 point something. I'd say 2.2, 4, 6, 2.7 maybe? They've only asked for one. So 2.7 is what I would choose. The other option here is, what's that, minus 0.7? Those are the two solutions. They've only asked for one of them though. So you just pick whichever of those two you want. Yeah. So that's really straightforward once you know what it's asking for. It's asking for solutions, and where is it asking for, where it crosses. Normally where it crosses the x-axis is normally the same question, I feel like. Question 27, I think these are the last two now. A solid cuboid is made of metal. The metal has a density of 9 grams per centimetre cubed. The volume of the cuboid is 72 centimetres cubed. Work out the mass. So density, mass, volume, that's basically the topic, isn't it? Density. This one we do need to know a formula for. I like to use a formula triangle, so I just remember that mass goes at the top. Density is mass over volume. In this case, they've asked for the mass, so obviously I would cross out mass. Do you see how that leaves me with the ones that are next to each other? I need to multiply. So I just need to take the density, which is 9, multiply it by the volume, which is 72. And that will give me the mass. It's literally that. That's all it is. But as long as you have the, the formula. I mean, without the formula, it's a little bit difficult, I guess. And you get 648. You see how, again, this one, 2 marks. Obviously 1 mark for some version of writing this calculation, and then 1 mark for the answer. And I think this is the last, this is the last bit here. So we've got part A, write 9 times 10 to the power 4 to 4.5 times 10 to the power 6 in the form 1 to n, where n is an integer. So vertically, they want this side to be 1, and this side we need to figure out. So I go, well, how do I go from 9 times 10 to the power 4 back to 1? How do I go from, could you do 72 times 9? Yeah, you can multiply it in the other direction, that's fine. In terms of multiplying generally, you can always multiply in whichever order. It doesn't matter the order. Obviously dividing is different, but multiplying, you'll get the same answer. So yeah, if you did 72 times 9, you should also get 648. That's also correct. So yeah, how do we go from any number back to 1? It doesn't matter that it's standard form. Like, let's say if I had, I don't know, I'm just making this up now. If I had this and it said make it 1 to something, how do I go from 5 to 1? I divide by itself, because 5 divided by 5 is 1, isn't it? So that tells me here, same thing, divide by itself, which in this case is obviously just a more complicated number, isn't it? 9 times 10 to the power 4. But because it's a ratio, we need to do the same on both sides. So what really I need to know is I need to divide the other side by the 9 times 10 to the power 4. So my calculation, what I'm actually saying is the calculation I need to do is 4.5 times 10 to the power 6 divided by 9 times 10 to the 4, which obviously I'll put in my calculator. It's meant to be a 4, there we go. 4.5 times 10 to the 6. And then 9. You can obviously convert them to ordinary numbers if you want, but I feel like you don't really need to. And it gives me 50. So technically that's 1 to 50. That's it. 1 to 50. And then part B, write the following numbers in order of size. Start with the smallest number. So in this case, you might want to convert them to ordinary numbers, right? So you can literally compare them. Obviously, this one here is already fine. So you can use you can obviously use the calculator for, I think it depends on your calculator. This one's obviously quite old. You obviously would have a newer calculator, I'm assuming. But I know that I could convert this first one. I mean, obviously you can do it yourself as well if you want. But if you're not sure, you see down here I've got this kind of times 10 button. I can just do that. Don't do the power of 4, just literally put 4 as the power there like that, and then it will tell you what it is. Now, my one, I don't think it does it for the negative one, so like this one, I don't think it does it for that. Yours might, because yours will be a newer calculator, so I don't know, but just check. You can obviously work it out yourself, or you could try and use the calculator. So that one's 56,250, 56,250. So you can see that one's already bigger than this one, isn't it? This one here, let's say I would work it out manually. Basically, the powers are just telling you how many times to move the decimal place and in which direction. When it's a negative power, this number is going to get smaller. So, for example, currently the decimal place is here, isn't it? Currently. Now it's going to go 3 times, and it's going to make it smaller. So that'd be 1, 2, 3. Do you see how that would go to here? 56. So that would become 56.25. Obviously, the 0 is kind of irrelevant now. So that's the smallest one so far, isn't it? This is meant to be a comma. I don't know if you can see that properly. Not a decimal. This one is a comma. And then this one, again, if I show you, I'll just show it to you, you know, figuring out yourself. The decimal place obviously here. Because it's a positive power, this answer is going to get bigger. So this one I was going that way. For this one I'm going to go this way. By 5. So 1, 2, 3, 4, 5. So that's going to go between the 2 and the 5 at the end, isn't it? So that would be 562.5. So you can obviously work it out yourself, or you could use the calculator, whatever you feel most comfortable with. Let me just rewrite this one. Now I can just see the order, which is the smallest, obviously this one. So do copy the original, 56,250. Maybe I'll write it smaller because I feel like I'm going to run out of space. 56,250 times 10 to the minus 3. That's my smallest. Then I had the 500, which is this one, 0.005625 times 10 to the 5. Then I had the 5,000, which was just as it was, wasn't it? 5,000. And then I had the 56,000, which is the 5.625 times 10 to the 4. So that's in order. And then that was the last question, actually. Yeah, that was it. Now it was 2 marks, so just in case you're wondering, let's see how they spread out the marks. So they're saying if you did the correct list, but with 1 error, so let's say you got 1 of them wrong, you'll only get 1 mark. So if you get 1 wrong, then you'll get 1 mark. Although I guess if you get 1 wrong, you get multiple of them wrong, don't you, technically? But yeah, so if you get only one thing wrong, then you get 1 mark, not 2. If you do the correct list, but let's say, see how they said start with the small list? If you started with the biggest and went to the smallest, they'd only give you 1 mark, because obviously you have to follow the instructions. What was the other thing? If you wrote, I think, if you wrote like this, yeah. If you write this, I think they give you 1 mark. So for one of those things, you get 1 mark. Obviously, if you get it all correct, as I've written it here, then you get the both marks. So that's fine. But yeah, just so you can see why you'd only get 1 mark is if you get one wrong, basically, or if you write it in the reverse order than what they've asked. But that was the last page. Yeah, that was it. So that is the whole of, as we said, the June 2023 paper 3 foundation tier paper. We'll be doing another one tomorrow, which I need to check actually. I think it was probably November 2023, but let me just check on my channel. And that will most likely be paper 2, because we're going to go alternating obviously between paper 2 and paper 3, because they're, as we said, all the same. Yes, so tomorrow, if you want to come at the same time, 5 o'clock, November 2023 paper 2. It's linked, it's already on my channel scheduled, and you can find the link for that paper and for that mark scheme as well in the actual description if you want to find it earlier and have a look through it beforehand. Otherwise, that is everything for this paper. Sorry about the technical issues at the start. Hopefully they did resolve themselves in the end, and hopefully for tomorrow it will be a lot more smooth. So thanks for joining me today, guys. I hopefully you found it helpful, and I'll see you tomorrow.